All right, so a couple of things off the top. I uploaded the first iClicker, so I've got a couple emails. If you guys have showing up to either 0 or even just as missing, there could be a couple issues. So one, even if you're using the app, you need to make sure that you're enrolled for this course. Right. So once you sign on to your profile, there should be an area where you can kind of enroll in courses, search the institution, Ball State University, find this section Econ 330 or this course and kind of enroll there. If you're showing up as a 0 missing, don't worry. Like once you get it correct, I can back. I've got everything recorded. It's just a matter of kind of getting it matched up. The other thing, if you're using a physical iClicker, you still need to register or enroll in the course as well. Kind of on website or kind of using your phone on the iClicker under your iClicker profile. Also, make sure your remote is registered both under that iClicker profile, but also on Canvas. Right. So there's that iClicker registration on Canvas. If for whatever reason it's still not working, I had someone with, I think, I don't know, their remote was registered from a previous year and they removed it and then kind of registered it and then it kind of syncs up okay. So if you're still showing up as a 0, maybe going back on re-registering your remote on Canvas just to double check. Okay. Any questions related to that? And like I said, if you want to check with me after class or something to see if make sure it was working today, I can pull it up and kind of double check. What else was I going to mention? Oh, yes. So I also put up the first homework, right? So you won't be able to work through all of it yet, but you probably could kind of chip away at a couple of the questions. After next week, I think we'll cover everything that should be on there. So if you're working a little bit on it now, but also throughout next week, that'll kind of help prevent you from having to kind of cram for it right before the due date. Okay. Any questions from me before we kind of get going into that? So I kind of skipped over this slide last class, so I wanted to kind of connect the two thoughts, and I knew I need a little more time. So we talked about marginal production, right? So that was the change in output, or we said for us the change in the number of wins from adding additional talent, right? That was an additional production or additional wins expected from increasing the amount of talent that we have. We're also going to have a marginal cost associated with this. So anytime we're talking about something on the margin, it's the change in that variable. So marginal cost, the change in the cost divided by or from a kind of change in the number of wins, right? If I want to get one more win, how much more am I going to have to spend? Right? So you can kind of think about it as, well, initially, I might be able to add kind of, 1 unit of talent, and I might get a whole win out of that. But then my second unit of talent, I only get half a win, right? So kind of think about in this scenario. So let's say I add 1 unit of talent, right? So my marginal production might be, right, so the change in the number of wins over the change of, we'll just call this talent. It could be offensive, defense. We could break this down, but just for the sake of this example. So maybe for the very first unit of talent, so kind of think about the talent we're adding, maybe the number of wins that get added are an entire win. Second unit of talent, maybe I only get half a win. Third and fourth. That should be enough to make this a point, right? So you can kind of think about it here. Let's say every single unit of talent has the same cost, right? Now, I don't think about this as like individual players. You can think about like each player might, be worth 20 units of talent or 10, right? But for every unit of talent, we'll pay the same rate, right? The player has 20 units and we have to pay them 20 times as much, but we're paying the same per unit. So initially, what would my marginal cost be, right? Well, if I want to get my first win, how many units of talent do I need to add? Well, just that first person, right? So whatever the cost is, my marginal cost will be, let's say the cost of talent is $1,000, right? So the change in my cost would be 1,000 from a change in the number of units of talent I had to add, which I just added 1. So I get a marginal cost of 1,000. Right? I then think about, okay, what if I want to get my second win? Well, there I have to hire the next 3 units of talent or pay for the next 3 units of talent just to get that second win, right? So for my second win, I've got 3 different units of talent. So I have 3,000 was that change in cost from kind of a change in the total number of wins, or sorry, the change in the number of wins that I had. Actually, I'll write this up here so we have this as a reference too. All right, so the change in cost divided by the change in the number of wins, 0 to 1, and then 1 to 2. So the change in the number of wins here, at least the way I have it constructed, will always be 1, makes it a little bit easier. So you can kind of see here, for that first win, my marginal cost is 1,000. For the second win, it'd be 3,000. And then if I want to go to the third win, maybe I've got to hire 10 units of talent, right? So this idea that because the marginal production, like if I wanted to calculate the marginal production for each one of these units of talent, it's decreasing, right? Each unit of talent is adding a fewer and fewer number of kind of wins. Then because of that, my marginal cost to increasing wins is going to be increasing. Right? So this is why we kind of have this increasing marginal cost, and it kind of makes sense. Like once we get like think about like Alabama football, if they're up to like the 100th unit of talent and they start adding more, they're getting barely any higher number of wins out of that. And so if they really wanted to go from like guaranteeing, I don't know, 11 in one season to 12-0, like you'd have to pay a lot for, right? The marginal cost would be really, really high. Okay. Any questions on that before we keep moving on? That should be a concept that you've probably heard before. I did skip over that, so I wanted to return to that. I also kind of skipped over this. So I just stole this from the book because that was just a nice example for us. But we can think about, and this won't be like the most common thing that we see in the sports industry, but there are some situations where it makes sense to look at it, especially once we start talking more about the labor market. Well, you think about here, let's say, I don't know, I've got some ticket market. So here's my demand, here's my vertical supply capacity, right? We talked about that last class. Excuse me. And I don't have we don't think about this as a monopoly. Excuse me. So where the supply and demand, that's where the equilibrium point's going to be. So we'll sell out, and the equilibrium price would be $100. Right. Problem is, let's say this is for a college basketball team, and I know that my college students, don't have $100 to spend on the game. Right. I know that the general public might, but for the students, I know that, I don't want, they're already attending university. I don't want them to pay as much. So I impose a price ceiling and say, look, we'll offer these student tickets at a much lower price. Right. You can't charge a price higher than this for these student tickets, right? So what would that do in our market? Well, you kind of think about it here, we're still going to hit, right, at this pricing. Like people would want, like a lot more people would want to buy these tickets, but right, we're limited by capacity. So here, it really wouldn't change the number of tickets purchased. It's just going to kind of decrease the price, right? Now, if we weren't at capacity, so let's say, I don't know. What do I want to do? So let's say demand was something like this. All right. Theoretically, what should my equilibrium price be here? I think I saw something. 0. Yeah, right. I'm actually hitting my supply curve on the x-axis. Price ceilings don't even make sense if I'm not selling out to capacity. All right. Now, if I have like a truly perfectly competitive market, what might be more likely is I see a monopolist in this market, right? They're going to maximize where marginal revenue hits my marginal cost. Remember, my supply curve is running along the x-axis and then vertical. So we're going to get this equilibrium quantity. And now we've got a higher equilibrium price. And now, okay, yeah, it still might make sense to impose a price ceiling now, right? And now if I impose this price ceiling and say you can't charge this higher price, well, what's going to happen? The monopolist says, okay, if you force me to only kind of sell this price, I know that the number of units demanded will be out here, right? And so we would kind of have the price set, at that price ceiling, and we should see, I guess we'll call this Q star, 2 stars, right? We should see kind of an increase in quantity. Now, that's if we're not selling out of capacity and we had a monopoly in the ticket market. If we had something where we're meeting capacity, right, all bets are off. Okay. So like I said, we might use this when we talk about like player minimums or maximum, or player maximums, sorry, for price ceilings, and then price floors, we would talk about minimums. So scroll forward here though for a little bit. So I want to make some more statements about these price ceilings, right? So let's say we impose this price ceiling, right, where we lower the price from 100 down to 15, but we still have, selling every single ticket, right? Demand is still high. Well, one of the problems here is I don't know who's getting whatever QS is. Let's say it's 1,000. I don't know what 1,000 people are buying these tickets, right? I'm not guaranteed that it's the 1,000 people who value it the most, right? Because now at this lower price, well, now all these people are willing to pay this lower price because their marginal benefit is greater than that. Before they weren't, because 100 would have been above whatever their marginal benefit was. So by lowering this price, having this price ceiling, I don't know if these are the 1,000 people or if these are the 1,000 people that are going to get those tickets, right? And it's just, there's more variables, first come, first serve, if it happen, whatever they're doing in their life. It's not going to strictly be based off of their marginal benefit or their ability and willingness to pay. Okay? So we impose these price ceilings, right? We can't ensure like who's getting these tickets. Now, if I limit this, right, on the unless I limit this to having one ticket per person, it could be that one person buys all the tickets, right? If I buy these blocks of tickets, what can I now do? So let's say I know that this capacity of the stadium is 1,000, right? So if we think about this, let's say someone even down here on the demand curve sees, okay, or sorry, right here on the demand curve is like, well, yeah, that price of that ticket is still above my marginal benefit. But if I buy all these 1,000 tickets at $15, I know there's people up here who would pay a lot more than $15, right? Everybody up there would be willing to pay $100 or more. So if I buy these huge blocks of tickets with this price ceiling, what's going to happen is we get things like scalping or people reselling things on StubHub for higher prices. I have not followed it. I know there's something about Taylor Swift that this is a perfect example for, but like the idea is that if you have people buying these huge blocks of tickets, they can drive the price way up, even though they paid this lower price ceiling, if there's people out here who are willing to pay more. And ultimately, you could argue whether or not this is like moral or what. I mean, these people are taking the risk, right? They may not be able to find somebody who wants to pay a high amount for these tickets. But in the end, who's ending up with a ticket? Like if this person pays $15 for it, and they can then turn around and sell it to this person for 100. Well, with or without the price ceiling, that person would have paid $100 either way, and they're still ending up with a ticket at the end. It's just that some of the money is now not going to the stadium or the venue; it's going to the individual who took this risk. So I wouldn't say it's like an economic like loss or a negative thing, unless we're trying to protect some of these venues if they're not able to kind of make as much money as they have. Maybe we want to protect those. The student kind of ticket example, like a lot of them will do this, but then a lot of universities will do this, like especially at high quality football, basketball programs. But what they'll do to prevent the student from reselling tickets is actually require that you have a student ID when you enter the venue, right? So there are kind of tricks that we could use, even setting these price ceilings to ensure that we don't get this resale. Or limiting the number of tickets that you can purchase to like one would be another way to prevent some resale stuff going on. Okay. Is that making sense? Any questions on that? It shouldn't be too bad. I think I have this slide empty so that you can do something here. So what if instead I had a price floor, right? So it doesn't really make a whole lot of sense for our ticket example, but I'll show you an example that you could see for a price floor. So let's say this will be the first kind of look that we get at, and I'll go over it in more depth as we progress through the semester. But let's think about a labor market. Is anybody taking labor economics here? So, okay, some of this will be really easy, right? So we're going to end up having some demand curve for labor and some supply curve for labor. right? Teams are going to want to, hire or pay players to play for them. Players are willing to play for teams at different prices, right? The price is now the wage or the salary that the player is getting, right? Generally think about it as wage. For all the examples, we're going to be thinking about salary, right? Whatever their contract is. Okay? So there might be some equilibrium. Actually, we'll call this one wage and quantity. If for whatever reason someone comes in and says, hey, look, I'm going to put a price floor. And I'll get out of the way in a second. Or a league minimum on salary, right? You can't pay players below this amount. So maybe this is like the labor market for your bench players, right? The player, they don't add a lot of value to the team, and so they might be paying them a pretty low wage. Well, the players union comes in and says, well, look, we want to help out, the kind of lower quality players in our league. We're going to, in the next collective bargaining agreement or whatever we have with this, whatever sport we're looking at, whatever professional league we're looking at, we agree that they agree that we should have league minimums to help these players out. Well, what's going to happen is, we will see the equilibrium wage goes up, right? Because there's no way you can get away with paying below that league minimum now. The problem is, there's a lot of players who want to supply their labor at this higher wage. There's not as many teams who want to pay that wage, right? There's not as high of demand. So what ends up happening is at that wage, we get fewer of these players hired. So how would this play out in practice? Well, unless you have like roster maximums or like that you have to have a complete roster. Actually, this is a really good example in NFL what these teams want to do. It's always good to have more practice players. The problem is if those practice players become more expensive, I might not want as many of them, right? I might not have as many guys on my practice squad, or I might not be paying if I have to pay these higher league minimums, right? So we might see this reduction in the overall number of workers here, right? But we would see for those who keep their jobs, right? Everybody here is losing their job, right? All these players here are losing their job. For those players who kept their job, they're getting this higher wage now, right? So price floors, we can kind of generally think about these league minimum salaries might actually drive there to be fewer kind of professionals in that league, right? And we shouldn't be thinking about like starters. Like I said, it's just probably playing out more so at league minimums, who's making those, your reserve or your bench players, practice squad players, things like that. Okay. Any questions on that before we keep moving? Okay. We did all this last class. Talked about demand shifts, tickets. We did not do this. Although I might hold off on this until we talk more in depth about the labor market. So we'll kind of skip over that slide. And we'll start with, in the rest of class until we get to the paper we're going to talk about today, talk about profit versus win maximization. So this is going to carry over into next week, but we're going to start thinking about, okay, look, we talked about what's the output of these teams. It's going to be wins, right? So, maybe I want to try to maximize the number of games that I win, but every win is costly. Remember, we started out today saying, if I want to start winning more and more games, my marginal costs are increasing. At some point, the additional revenue that I earn from having a higher quality team with more wins isn't going to compensate me for the higher marginal cost that it took to get that higher number of wins, or the higher revenue that was generated from those higher number of wins. So we have this battle between profit maximizing and win maximizing, right? If I solely want to profit maximize, it may be at a lower number of wins than if I wanted to win maximize. Right? Win maximizing is going to be the highest number of wins that I can financially afford, right? Profit maximizing, it's a number of wins that would, cause the highest amount of profit. So what is this going to look like? How can we kind of model this, right? So for traditional companies, we think they're going to maximize profits. However, we might want to maximize wins. There's a trade-off. I can already mention why, right? Because wins are costly, right? As I want to win more games, my costs are increasing. In fact, they're increasing at an increasing rate. Right? We saw these marginal costs were increasing that I had before. We also have revenues are a function of wins, right? but it's doing so at a decreasing rate. So, excuse me, as I win more games, I'm generating more and more revenue, right? As I win more games, like going from 0 wins to 1 win might add a lot more to my revenues than going from, you know, a football, if we're thinking about a football team, 16 to 17 games, right? If I win 16 or 17 games, I'm really, really good. Yeah, it's probably not going to increase my revenues that much, right? But maybe like in the middle, if I go from winning like 8 to 9, right? I go from like outside of playoff contention to playoff contention, maybe I'm seeing pretty large increases in revenue. So we know that if we win more games, revenue goes up, but we also know costs are going up as well, right? So what we really need to do is think about, well, what are profits and really the difference between those. So if this is, you know, eventually we're going to get to a point where the additional revenue added from one more win is less than the additional cost, and we'd actually start decreasing our profits. So we've got revenues and costs as a function of wins, and we can kind of think about our profits are just going to be the difference between our total revenues and our total costs. Okay. So what would the optimal number of wins be? So just to start out with these models, I'll kind of make them a little bit more simple than probably what they should be, but that's okay. The same principles would apply if we allowed there to be a increasing marginal cost curve. It would just be a little bit more tricky, right? So initially we'll just start out assuming that you want to win a certain number of games. We're going to have this constant cost. Like I said, it's a little bit, we know that it's kind of wrong, but we'll just start out with that simplifying assumption. So, actually, sorry. Think about kind of every single win. And if we wanted to graph the marginal cost, we're going to have just kind of constant marginal cost simplifying assumption to start out with. Okay. We also know that we generate more revenue from wins. And how much revenue do we generate? Well, it's going to be from whatever fan demand, right? So you can kind of think about it as the additional revenue that's generated from, you know, going from winning 10 extra games, 70 to 80 might be a lot more than that if I'm going from 95 to 105. Okay, we've kind of alluded to that. So we've got marginal revenue is decreasing with the number of wins. Okay, so you can kind of think about this as I've got some demand curve for wins from this team. And as a result, it generates a certain number of additional revenue, or kind of this twice as steep marginal revenue curve. So I know that a profit maximizing team, just like, you know, profit maximizing company, will choose the optimal output, the optimal number of wins. How do I want to write this? Give me 1 second. So if I want to do, here we go. Sorry. They're going to set output where marginal cost hits marginal revenue, right? At that point, we would say that's the profit maximizing number of wins. And remember, we're always like expected number, right? The targeted number of wins. Like these decisions are made before the games are played. So this is like the targeted number of wins based off of how many units of talent we added. Okay. Any questions on that before we keep going here? So this gets a little bit tricky. And I left this slide open for this. Where would the win maximizing point be, right? So if we keep demand linear, what ends up, and this is why I kept marginal cost constant. So you can kind of think about this as 5 profits, total revenue minus total costs. I can rewrite this as total revenue over right. So here, my total cost will just be the number of wins I want to target times the marginal cost of each win, which I've kept constant. So just the number of wins times whatever the marginal cost of a win was, right? I rewrote this kind of tricky. I multiplied and divided by the same thing, so I didn't change anything. But notice here, now what do I have? I have the number of wins they're targeting. And this kind of represents average revenue, right? So at what point is it going to be where my profits are equal to 0? It's when this average revenue is equal to marginal cost. So I can rewrite this as this, right? So I know that the point at which profits are zero is when average revenues become exactly the same as my marginal cost, which if we work through a linear demand curve, we can show that my average revenues, right, would actually just be the same as my demand curve, okay? So the win maximizing point is where my average revenue is equal to my marginal cost, because I can't spend past that. If I go negative profits, what happens in the long run? I have to leave that market. I can't operate at negative profits forever, right? Unless I might be able to take some money out from other businesses, but eventually, right, about year over year, in the long run, eventually I would have to kind of leave that market, right? So to win maximize, all I can do is drive my profits down to zero. So that point is going to be right here where my marginal cost curve hits that demand curve, which will be kind of, because it's linear, my average total revenue as well, okay? Any questions on that? And, you know, not to go, I don't want to go too far into the mathematics here, but just to give some support as to why this average revenue is the same as my demand curve. Remember, total revenue would be price times quantity. Well, here it's like the price I'm getting paying per win, or that people are paying per win. So it's like how many tickets I'm selling. Like it'd be a very complicated thing to figure out what this was, but like how much each win would drive up ticket sales plus apparel sales, all these things. My quantity is the number of wins. So notice if I'm looking at this average revenue, I divide by the number of wins, it would just cancel out to being whatever the price I'm getting for each win, which is my demand curve, right? Price is a function of the quantity, price is a function of the number of wins. So that's why we kind of have our demand curve being exactly the same as our average revenue curve when we have linear demand. It's a little bit more complicated if we had some quadratic equations. Any questions on this? We keep moving here. So we can see if I got profit and win maximizers, what's going to be true about the number of wins they target? Well, profit maximize target a lower number of wins, right? And that kind of intuitively makes sense, but this is how we would model it, okay? So another way of visual, I stole this from a book because I like this a little bit, but you kind of imagine like if I'm looking at my total revenue curve, I said it was increasing at a decreasing rate. If I had kept my marginal cost constant, my total cost curve is just kind of linear, right? So I can think about it as this would be the win maximizing number of wins, right? This higher number of wins because total revenue is equal to total cost. That's where my profits are zero, right? So just as a kind of reminder here, the reason why that's the win maximizing number of wins is because that's as far as I can spend, right? Right down to the profits being equal to zero. And then you think about, well, what would maximize profits? Well, that would maximize the distance between total revenue and total cost. That'd probably be like somewhere like right about here, right? Which would be at that lower number of wins. All right, so we've already talked through all this. I don't think there's anything else I want to say here. Okay. I'll move this so we can kind of see. So we always know the win maximizing number of wins is going to be higher than the profit maximizing number of wins. Whoops. Let me see here. We got about 20 minutes. I'll introduce one more idea here. So let's say I've got two teams. Okay. So one thing we'll start talking about, a main driver of some differences that we see across leagues or even within a league, are small versus large markets, right? So you can kind of imagine like these demand curves for wins, right? So maybe this is, what do I want to do here? Let's say, I don't know, Chicago, and they would have their twice as steep marginal revenue curve. And then let's say, hold on. I can't use Chicago for this one. I was doing it backwards. So I want my small market team first. So let's say I do Indianapolis, right? It's like 1.5 or something more close. Maybe I think it might be closer to 2 million people, but still a pretty small market when you're talking about relative to cities like New York, LA, Chicago. So Chicago's demand curve probably looks something like this, right? Much higher, right? Because every single win in Chicago, there's just more people. It can generate a higher number of people attending games, higher number of people purchasing apparel, higher number of people, right? You name all these other revenue sources, which we'll get into a little bit next class. And I might introduce it today, but we'll talk a lot more about it next class. The amount of revenue generated from that win in Chicago, right? Same number of wins doesn't generate near as much money in Indianapolis as it would in Chicago, right? I don't think that's a wild, it's anything crazy. All right, so these larger markets, we're going to have these higher demand curves. We then think about each team really is facing the same labor markets, has the same players available. Once again, we'll keep it constant for now just to make it a little bit more simple. But if we have this kind of constant marginal cost, right? Well, then they're both going to kind of face that same constant marginal cost. Let's say they're both profit maximizing. So if they're both profit maximizing, so Chicago, Indy, right? Well, then we would predict that the larger market team will target a higher number of wins, right? And that's because they face the same cost, but they can generate much more revenue in Chicago than in Indianapolis, right? Now, what if instead your small market teams decide, okay, we're going to win maximize, right? Well, they can spend all the way to this point where profits are equal to zero and kind of close that gap, right? So if smaller market teams win maximize, potentially we can kind of see them close that gap in between the number of wins. Now, is it actually the demand curves this far apart? Probably not. But what might be more likely to be the case, I'll draw this down here. So we'll do this constant marginal cost. Let's say here's Indianapolis. Let's say use different colors to make this little value. Let's say, I don't know, maybe instead of Chicago, we want to do, oh, it's a decent sized city. Let's do Detroit. Okay. So we have a larger market team, right? So Detroit versus, these don't look like I's, but these are supposed to be I's. If you want to write out Indianapolis or Indy, you can. In this scenario, if Detroit was profit maximizing, they would be where? Well, where is their marginal revenue at marginal cost? Right. So didn't leave myself enough room, but right. Detroit is profit maximizing. They're going to target where marginal revenue is equal to marginal cost. If Indianapolis decides to win maximize, well, what can they do? Well, they can actually spend all the way up to the point where their average revenue is equal to marginal cost, or they're kind of hitting that where that demand curve hits the marginal cost. Now we've got, if the small market team win maximizes, potentially they can actually surpass where those large market teams are. So, the initial drawing, you might be like, well, hell, even if they're win maximizing, like they're never going to be able to compete with these large market teams. And the answer is, yeah, if the large markets can generate this, significantly more revenue so that the demand curve is way far away from the small versus large market, yeah, there might not be anything these small market teams can do in the long run to really compete with a larger market team, right? However, if that demand difference, right, for the number of wins from those teams isn't as pronounced, and right, it is driven by population, but I'll come back to this second. Sorry. If the demand curve difference isn't that much, sometimes my brain works faster than I talk. So if there isn't a big difference, well, then potentially the small market teams can compete with these larger market teams, right? It's just that they'd have to be having a different behavior, win versus profit maximize. right? And, you know, maybe they don't want to win maximize, right? So let's say Indianapolis, like, they want to win more games. They don't want to profit maximize. You don't have to completely win maximize. You could just say, well, look, I know that I'll earn the highest profits if I'm down here, right? Targeting a lower number of wins. Yeah, maybe I want to have some profits, but target a higher number of wins. I could still surpass the large market teams if they're solely profit maximizing, but still kind of have some level of profits there, right? So it's unlikely. I'm using the extremes of profit win maximizing. It's likely most teams are probably doing something somewhere in the middle, right? They're probably actually, I would argue there's probably some that are just profit maximizing, but right, the majority of them are probably gonna be somewhere in the middle there, right? Yeah, they're not maximizing profits, but they're spending a little bit more so they can get a higher targeted number of wins. Okay. Any questions on this before I keep going here? Okay with this? So the one thing I was going to mention, it gets a little bit different. So I was talking about like, I'm comparing like the population of Indianapolis to the population of New York. These demand curves are probably really far apart, right? I'll use a better example. So instead of Indianapolis, if I was comparing to New York, actually here, if I compared LA, very large city, the demand curve for wins to the demand curve for wins from Edmonton in Canada, you might say, well, LA is the large market team. They can generate so much more revenue. Well, what if I'm talking about hockey? Right? The demand is not just driven solely based off population, right? It's the marginal benefit people get. So in Edmonton, there's a much higher demand to watch their hockey team win games than I would guess like in LA. Right, LA is not. It doesn't strike me as having like the wildest hockey fans, right? And so, depending on the sport, right, it's not just population or income differences driving these demand curves. Although they will drive that a large portion, it could just be general interest in the sport. All right, so every market's going to be a little bit different in terms of how much difference we see in those large versus small markets. And an interesting question, like maybe for the project, and I'll mention that some other stuff about that here in just a second. You know, you could think about like, well, do I see like a bigger gap in between large and small market teams in the number of wins in this league versus this other league, right? Because maybe this one league is you know, comparing hockey, like I know there's much difference demand curves in Canada for hockey than there's in the US, and it's not strictly based off of population, right? This definition of kind of large versus small market. Okay. Does that make sense when I'm getting that? So I mentioned the project. And we'll talk about different types of revenues next week. But if we go to Canvas, I put up a thing where you can upload your project proposal. I had a couple people already reach out to me, and I haven't had a lot of time this week, but next week I'll start chipping away at some of those, getting some data back out to those who have contacted me. Or if you upload in the Canvas, I'll kind of keep checking so I can kind of see, you know, if you uploaded your proposal and kind of I can get an idea about what data would work. Like I said, if you have questions, always feel free to email me or run something by me. But I put up this project files folder, and I've got an example project. So this was like what I would consider like an A+ project. This was a project that somebody did. Actually, I think this one, I think it was my very first semester that I taught this. So I've got the example project. And then I've got the components of the project kind of labeled and listed out a little bit more in detail. And then I also have just a list of ideas. So these are just some like different types of ideas that you could do. I don't know. I try to give some of them clever names, but anything, you know, nothing's off limits. Like this is just if you're having a difficult time, even getting some ideas going, kind of can read through this list. Okay. Any questions on that proposal? Like I said, I think I've got it in the description, just a couple paragraphs, like 1 or 2 paragraphs, kind of writing out the question and the topic that you're interested in, why you're interested in it, and then maybe some potential ideas of what kind of variables or what the data you would want to have to answer that question. Okay. So I'm going to pull up under files. We'll go to this stock returns personal conduct. So this will be the last week where I kind of walk us through a paper. From here on out, I'll kind of expect that you at least skim through or read these papers enough to get a general idea of what they did. So this, I don't think has been published yet, but I have got my hands on it. I thought it was kind of interesting. So it might be, we might run into some, might be some typos. Some of these ones that I use are preliminary. People are still working on them. So we're always thinking about like research that's been done. We shouldn't just accept it that it's amazing, right? We should always question it. And especially if it hasn't been published yet, there might be some holes in what they did. So their general interest, the question, right? We went through their abstract. This one is really kind of nice. It breaks down the question, right? And then kind of gives us like what their methods were, what data they were using, a brief summary of their results, and then kind of maybe some policy suggestions or some implications of the result. Here, if you just read the abstract of this paper, you'd have a pretty good idea like of what they did, right? So we'll read through this abstract, and what they're really trying to get is, okay, are stock prices impacted by off-field incidents by athletes, right? So if I've got a player, Ray Rice, and if you don't know what he did, Google it or YouTube it. But that probably didn't go too well for the Ravens when he was on their team, right? They probably had some backlash. Now, stock prices, it's hard to, we're thinking about teams, it might not be, we're not talking about the team stock prices, but if I'm an advertiser, M&T Bank Stadium, I probably don't want to be associated with the Ravens when something like that happens, right? So do these athletes off-field issues, are they having impacts on the stock prices of these teams that are kind of affiliated, or sorry, these companies that are affiliated with these different teams? So that's their general question. Looks like they're looking specifically at the NFL, and they're also, so they've got what, 17-year time period. And I also believe what they do is they look at two different time periods within that when the NFL kind of updated its personal conduct policy, and then kind of see, did that have any change on whether or not off-field behavior impacted these companies, right? So their findings, you can kind of see some decreases in stock price around these personal conduct issues. But once we have that summary, we might want to be a little more interested, maybe to give us a bit of a better understanding. Once I read the abstract, like I said, I usually then scroll down to anywhere where I see an equation. I might be more interested in the data. I could read a little bit more about the data here, but it's NFL data. Yeah, they even mention here the Ray Rice case as being kind of some of a motivating idea here. So we'll scroll down until we see an equation or a table, right? So notice here, if we look at preliminary papers, sometimes the tables, the convention, is they'll all be at the end. It actually makes life easier for us, right? Because I can just scroll all the way to the end and kind of look at the tables. But if I'm interested in kind of the regressions they were running, like they break some things down here, can kind of go all the way to the bottom. Here's my tables, right? So here's just some general summary statistics. They define these different off-field issues into all these different subcategories, right? If we then look at this table, they do kind of an interesting thing. Okay? So the regressions that they run are what we call event studies, right? And so all we're doing is saying, okay, look, take the stock price of this company that was associated with the team where we had an off-field incident, right? And then we're going to have an intercept. Actually, I should write this. Here's our intercept. And then we're going to do an indicator for what was the stock price. This will be like, sorry, different times, right? So every single day we would have a stock price. That would be like our data set, right? Every day has a stock price. We're then going to create an indicator for, was that day 10 days before one of these off-field incidents? And then we're going to include another indicator, or just a 1-0 variable, was it 9 days before the incident? We'll kind of then do that all the way up to the day of the incident, 1 day after, 2 days after, 3 days after. So if we expect these to have any effect, hopefully for the days before the event, right, nobody knew that was going to happen. We don't see anything going on there, right? So sure enough, we look here, maybe there is some kind of negative effects here on some of this team sponsors, but stadium sponsors, we kind of see positive values here. That makes a little bit more sense. I don't know, team sponsors, I don't necessarily know if I could even name team sponsors, but I can tell you some of the names of the stadiums, right? And so maybe that's why we can kind of see something here going on there. But one thing I want to kind of use this paper to point out is we can get these estimates. We can get what the effect of being 10 days before the incident was. We can get the effect of being 5 days after, right, from these different coefficients. Okay. However, they're just estimates. We're just using some sample data. And so we have to kind of revisit this idea of, well, can I say that it's statistically different from zero? So do a quick little thing review here. But I'm sure a lot of you like to forget this stuff. Hypothesis testing is going to be something that we have to think about with linear regression, right? We're always going to assume that these slope coefficients or that whatever variable we're looking at has no impact on our dependent or our y variable. We're always going to assume that there's no effect. If we can find enough evidence, right, that it's different from zero, we can then reject this, right? So I had someone ask, why did we do it this way? It's just math doesn't always line up with how we talk, because it's kind of like, well, I'm rejecting that there's no relationship. I'm kind of double negative, right? But that's just, that's just how we have to set it up. We have to assume it's equal to a specific value, and then we try to see, can we reject that, right? So we're going to assume there's no effect and then try to reject that, okay? How can we reject it? If we can get a p-value on that coefficient estimate, that's less than these alphas we set. So what are the alphas that we set? 0.01, 0.05, and 0.1. Those are kind of our three benchmark alpha values. So they would correspond to 90%, 95%, and then 99% confidence. Okay. So generally, and they don't do that. Actually, let me see here. So this paper does things a little bit differently, and they're not giving us the p-values, right? So this is a good thing. I generally think that papers are better if they use the p-values, but they may not always do that. Yeah. They do. It's the asterisk one. So the one where you have. Yeah. So the stars. Yep. Yeah. You're getting. Yeah. You read more than I thought anyone would. So here, what they're actually giving us. Let me see if I get a good one. So you can see that they're really large. Like negative 2.7 here. That's not a p-value. P-values are probabilities. They're giving you the test statistic that would correspond with that p-value. It's way easier just to use the p-value approach to reject it and kind of worrying about kind of test statistics and comparing the critical values. So a lot of papers will give you the p-value underneath the estimate. This one gave you the test statistic, but that's okay because they use the good convention, which is stars, right? Anytime you put one star next to your coefficient estimate, that means you can reject it at the 90% level. 2 stars, 95. 3 stars, 99%. Right? So even if they don't give us the p-values, they're at least letting us know which of these estimates are significant. Right? And generally, when we're looking through these results, like sometimes a non-result is interesting. Like if I'm up here and I'm seeing like none of these are significant, well, that meant that this, from 2 to 10 days prior to the incident, there was no effect on the stock price. Well, that's what we would expect, right? We can't actually reject that null hypothesis that those coefficients are anything different from zero, right? However, once we get to some of these days, kind of post, right? Which is kind of weird. Like we would expect there maybe to be a negative effect. Well, there was on the team sponsor here, and that was significant, but not on the stadium sponsor. You don't really get any significance there. There's something weird going on here, which I'm guessing this has to do with like when information is released and when people actually find out about it, like through traditional media sources. So maybe that's why I can kind of see some weird things going on one day prior to the incident. You notice the day of the incident, there's also kind of a huge negative effect on the stock price as well. And then as we get further out, it doesn't look like we kind of have any effects. We get some weird stuff. This is probably why this paper isn't published, because there's no reason why we should be getting a significant positive effect 6 days after the fact for the stadium sponsors. There's probably a lot of other confounding factors that they don't have enough control variables on the right-hand side, right? So they set up this nice event study, but right, you would also hopefully want to be controlling for other aspects, other characteristics about the companies as well that might impact the stock price. So they don't have a great set of controls in here, which is why we might see some weird things going on. But I don't know, I think it's kind of an interesting kind of paper to look at. If we then wanted to kind of keep going down here, they actually find that after the personal conduct, so they then look at a time period with after the personal conduct, they find some large negative effects. I don't know. It's kind of an interesting paper, but I wanted to use it more so to bring up this idea of p-values. Even if the tables don't show us the p-values, they should be using this star notation. And when you're looking through those tables, we're really looking a lot of times for those stars. What can we say has an effect on that dependent variable? Or what can we say we can reject that there's no relationship for? Okay. So moving forward, we'll probably spend a little more time on some of these papers in class. I just want to kind of give you a rough idea of how you should be kind of reading them. Just abstract, generally look at the tables, any regression equations that they include would be good to look at. And I'll start asking some more questions on them. Like I could have IQ questions ready for them, starting with next Friday. Okay. All right. Have a fun, safe weekend. I'll see you guys on Monday. If you have any issues with the iClicker, I'm going to be resyncing it later this afternoon. So if it still doesn't show up from Wednesday's class, send me an email and we'll try to kind of get something worked out.